Good day, everybody. I found this problem that a lot of people would probably categorize this as recreational math, but I thought it was worth going over here. So, a key aspect of a Fibbish number is any digit in the number is greater than or equal to the sum of the previous two digits. Okay, now that's not too. It's a little bit of a mouthful. We're not allowing for the digit 0. We're supposed to find the maximum Fibbish number. Now, so just some examples will serve to illustrate. Okay, the way this was defined in this competition, ARML competition, they didn't say that it was at least a 3-digit number, but that follows just from the way they defined it. So I just wanted to say that it's at least a 3-digit natural number with this property. And you can see 113 is definitely a Fibbish number. 112 would be a Fibbish number. Notice that 3 is greater than the sum of the previous two digits. Now let's hop here to the 4-digit tries. You have 3, okay, then you have 5 right here, which is greater than or equal to the sum of the previous two digits. Okay, and then you can carry on in this fashion. I'm not saying I'm listing them all, but hopefully these examples illustrate what this slightly clunky definition states. All right, and notice here we're in the 5-digit range, and also here we had 3 and 5, and then we did 8. But notice we could change it to 6 and change it to 9 and still satisfy the condition. Okay, and also this would be the biggest 5-digit probably, because notice if you swap around the 2 and the 1, you get a bigger number, but everything's still taken care of. Okay, now from these examples, we'll make a lemma. And again, I'm not gonna. Hopefully, this construction here will indicate this. The maximum Fibbish number must begin with the digits 1, 1, okay? And the reason for that is if you go bigger than this, the total number of digits will be limited. You see, if you go bigger, notice like right here, we just went to 2, and all of a sudden we just have a 5-digit number, and that seems to be the biggest 5-digit Fibbish number. I'm not positive about that, okay? But the minute if you do anything other than 1, 1 at the beginning, it reduces the number of digits in your potential Fibbish number, okay? So I'm going to make this claim, it's far from rigorous. We'll call it recreational claim here, but I think it's true. It has to begin with 1, 1. Otherwise, you get stuck at 5 digits here, okay? Now, so here's a 6-digit try, and notice it does begin with 1, 1, all right? And everything's satisfied, right? 2 is greater than or equal to the sum of 1 plus 1. 3 is greater than or equal to the sum of 1 plus 2. 5 is greater than or equal to the sum 2 plus 3. And similarly for 9, okay? But notice we could also consider 1, 1, 2, and then 3, 6, 9. And we could consider this one first, but notice that 9 is greater than, strictly greater. Remember, greater than or equal. So 9 is strictly greater than 5 plus 3 right here. 9 is strictly greater than 5 plus 3. Okay, but right here, 9 is just equal to 6 plus 3, which is what the condition states right here. Okay, so my claim, this is going to be the biggest, this is going to be the maximum Fibbish number. Okay, right here, we'll just point down here. Okay, so that's the answer, I believe. And then just a silly conjecture here, but there are no 7-digit Fibbish numbers. And again, by construction, you can see. If you agree with this lemma, it's just there's no way you're going to get past 7 digits, right? Like right here, the digit 9 is the maximum digit in the Hindu Arabic number system, right? So there's no way. What are you going to put here that would be greater than 9 plus 6, which is 15? It would have to be a single digit. Can't do. Now, what would be interesting is to do this in hexadecimal, maybe. Try hexadecimal with base 16. That would lengthen things, and that would be something if anybody feels like doing it. But hexadecimal considerations would make this slightly more interesting, I guess. But it's kind of a grind to go through this. And again, none of these things were rigorously proved. But I don't think there's any 7-digit Fibbish numbers with this restriction that you can't have 0. I think in the contest problem, you could have 0, so it was a longer number, I believe, you know. But I just eliminated 0 just to make it slightly more tractable, you know. But in any event, this is the answer. 112369 is a Fibbish number, and it's the biggest one. It's a 6-digit number. Thanks for viewing.